A company wants to compare the proportions of customers who prefer their original recipe with those who prefer a new recipe of a product. In a random sample of 400 customers, 220 preferred the original recipe, while in another random sample of 300 customers, 150 preferred the new recipe. What is the best estimate of the difference between the proportions of customers who prefer the original recipe and those who prefer the new recipe with a 95% level of confidence? So this question is asking us to construct a confidence interval for both of these samples. So we're going to be using the equation P1 hat minus P2 hat plus or minus Z star times the square root of P sub 1 times 1 minus P sub 1 over N sub 1 plus P sub 2 times 1 minus P sub 2 all over N2. So now let's look at the problem and determine the key values that we need to use our formula. Well, we have the random sample of 400 customers, so that's our N1 value. We know that 200 preferred the original recipe. That will make P1 hat, which is equivalent to P1, to become 220 divided by 400. And this ends up reducing to 22/40ths or 11/20ths, which is 55% or 55/100ths as a decimal. Okay, so in another random sample of 300 customers, so that's our N2, 150 preferred the new recipe. And since we're comparing it to the original recipe, we have to do a little bit of math really quick to determine how many preferred the original. So we can do 300 minus 150, and that is 150. So our P2 hat, which is equal to P2, is equal to 150 over 300. And that reduces to 1/2 or 50% or 5/10ths as a decimal. Okay, we also know that in our problem we are trying to construct a 95% level of confidence. So that means our Z star value, let me rewrite that. Our Z star value is going to be 1 96/100ths. And now we can substitute all of these values into our formula to calculate the answer. So P1 P1 hat is equal to 55/100ths minus P hat 2 is 1/2 or 5/10ths. And we have plus or minus our Z star value of 1 96/100ths times the square root of 55/100ths times 1 minus 55/100ths will be 45/100ths. And our N1 value is 400 plus 5/10ths times 1 minus 5/10ths is another 5/10ths all over 300. And we can easily cross out or replace this 55/100ths minus 5/10ths with 5/100ths. And now we can substitute this formula in both formats into a calculator to determine what our confidence interval is. So when we do it with the plus in between, we end up getting about 125 thousandths. And when we do the minus sign, in between, we end up getting about negative 25 thousandths. So that makes the correct answer to this question. Answer choice D.